Hi. So for part B of this question, we've been asked to prove by using the second derivative of c with respect to v that the cost is minimized at the speed found in question A1 for 2 marks. Okay. So we know the function c in terms of v. Okay, and again I've just used my knowledge of indice laws just to bring this v up. Okay, to have it in this form. And we know the first derivative. Okay, we can therefore say that dc by dv is minus 1500 v to the power of minus 2 plus 2 of 11. We showed that in the previous question. So we've been asked to prove by using the second derivative. Okay, so you should be familiar with this rule here. Okay, so it states that if a function f of x has a stationary point when x equals a, then if the second derivative of x, when you substitute a into this, if this value is greater than 0, then the point is a local minimum. Okay, so this is what we're going to be looking out for. Okay, we know our value v min, the minimum value of v, was 5 root 330, and that was in kilometers per hour. Okay, so what we're going to do is we're going to check by finding the second derivative and then substituting this value in and seeing whether that value is greater than 0, and hopefully it should be. Okay, so we can therefore say that d squared c by dv squared is equal to, and then we just simply differentiate again. Minus 2 times by minus 1500 is positive 3000. V minus 2 minus 1 is minus 3. And this constant differentiates to 0. Okay. So what we're going to do now is we're going to check when V is equal to 5 root 330. You should find that you get d squared c by dv squared to be 4.00 times 10 to the minus 3 to 2 decimal places. Okay, so because this is greater than 0, we can say that this point is a local minimum. Okay, so that's part B. And for part C, for 1 mark, we've been asked to state one limitation of this model. Well, there's many things you can say here, but one thing I've chosen to say is that in reality the lorry speed will in fact fluctuate, and the model does not take this into account. Okay, so the lorry is not going to go all the way, the whole journey, without stopping. It's probably going to stop, and it's probably going to accelerate and decelerate, and traffic lights, and etc, etc, etc. So the model has not taken this into account. The model has simply set up for one steady speed for the whole journey. Okay, so it hasn't taken into account any speed fluctuations, any stopping and starting, etc. Okay, so that's also part C done. So if you're having trouble with differentiation or finding max or min points, then do check out the links below in the description, which will forward you on to a few other videos and exam questions on this topic. And don't forget to leave a comment, like and subscribe the channel. Thank you very much, and I'll see you in the next question.